Hello, how you doing? Okay, so I cannot help myself. I've been listening to Coast to Coast. Richard C Hoagland, I love that guy. And he's talking about Comet Elenin. And there's just one aspect of what he's talking about that blows my mind. Now I'm going to please listen to this, okay? I'm gonna show you it, okay? One moment. You have to listen to this. If you don't listen to anything ever again, listen to this.
The IAU Minor Planet Center publishes, and I look at this number and it's, wait a minute, that can't be. He discovered it, Elenin discovered this thing when it was 19.5 magnitude? Okay, and I'm looking at the table right now. He took 4 plates, 4 CCD images, all of them 19.5. The next guy to take images and dump them into the system a couple nights later, it was 19.1.
And take just a quick minute, Richard, and explain to some people who are brand new to the show what this means when you say 19.5.
Well, we don't have the time. If you want to take calls in the last half hour, we do not have time. You have to go to my website.
Well, give us a highlight.
All right. If you take a tetrahedron, which is the simplest three-dimensional structure you can have in space-time, 3D, and you rotate it, just spin it in space.
All right.
A tetrahedron is an equilateral triangle, 4 of them pasted together. I'm sorry, 3 of them. And it has 4 sides, 4 vertices, 4 corners.
Like a pyramid.
It's basically a 4-sided pyramid. But the 4th side is not on the bottom, it's on the side. The pyramids in Egypt are really 5-sided. You know, they get 4 sides on each side and then they're sitting on the 5th.
That's right.
So this is a classic. It turns out Bucky Fuller's work was all based around tetrahedral systems. It turns out a tetrahedron is the simplest three-dimensional object that you can create in three-dimensional space. It's the first eruption out of the plane or a line, that kind of simple geometry. It turns out if you put it in a sphere and you rotate the sphere and you put one of the points, one of the vertices on either the north or south pole, like a planet, let's say the Earth, the other 3 vertices will pop up either inside the northern or southern hemisphere, depending on where that 4th vertex is located, at either 19.5 degrees north or 19.5 degrees south.
Okay.
And when you look at planets, even the sun, energy eruptions on rotating celestial objects all across the universe, stars, planets, all the ones we can see in this system, the major eruptions, the major energy upwellings are at 19.5 degrees, give or take. I mean, physics is never exact. It's like a margin, like a range, like a window. So it's kind of 19.5. Actually, the precise mathematical definition is 19.47, but we always round it to 19.5.
So the fact that you could even get close to it with a lot of things that you have talked about over the years is pretty remarkable.
It's impossible. So I start looking. Let me riffle through my sheet here. All right. What I tried to do then is I started looking at these numbers, and the 19.5s kept popping up. I said, okay, how do I put this in a statistical format to where I can actually calculate the probability?
Okay, check this out.
This whole thing is just by chance. And what you do with probabilities, you take the probability of any individual coincidence, and then you multiply it by the probability of the next coincidence. Probabilities don't add, they multiply. Which means if you have a string of improbable things that happen, bing, 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 run one right after another, the end of that string can really grow enormous very, very quickly. So I'll give you the kind of logic of how I did this first thing. How do I decide what the probability of Leonid Elenin discovering Comet Elenin at 19.5 magnitude would be by simple chance? Well, the brightest comet ever observed by astronomers was Ikaea Secchi in 65. That was 17th magnitude, minus 17. The dimmest comet ever observed is Halley with Hubble in 2003. It is moving way out toward the outer part of its orbit now after passing close to us in 1986. That's at plus 28.2 magnitude. So the total range is 45.2 magnitude. So the chance odds of discovering a comet at magnitude 19.5, that's plus 19.5, is 1 in 45.2.
Okay.
Okay? I mean, nothing to write home about. You take those odds to Vegas, you might win some money. So here's the next one. If you multiply, let me get this in sequence here.
All right.
The odds of Elenin actually visiting the Earth in any one period of time, in other words, any one particular day, is basically 1 in 365, right?
Sure.
Why is the closest approach on September 11th? Not the 9th, not the 12th, but the 10th and 11th. Now, why is it also the 10th? Because it starts in one part of the Earth, and then as the spacecraft moves around the sun, it's closest to the sun for a slice of the Pacific, a portion of the Earth, on September 11th. Now, September 11th, as we know historically, 10 years ago, was a hugely important date. But just forget that it's historically important. Just say, what are the odds that on any particular day that there would be something occur? Well, the odds are 1 in 365, right?
That's right.
So you have to multiply that 19.5 odds I just gave you, which is 1 in 45.2, by 365. Okay? Now, if you pin it down to the fact that it's the 10th anniversary, it's not 9 years, it's not 12 years after our 9/11,
It's
the one
10.
that horrified us, you have to multiply that by 10. You see how this rapidly begins to escalate up? So let me move through my view graphs here. Okay.
But are these are not numbers that people have created?
Oh,
they're,
no,
They're there, right?
They
They are what they are.
They are in the ephemeris. They're in the orbit of the comet. Okay, let me give you the last one that's really amazing. Well, two last ones. Elenin approaches closest to the Earth on October 16th. Remember, it's now approaching the sun. It'll turn around the sun in a hairpin turn. That's the way gravity and Kepler's laws work on the 10th, 11th.
And then here it comes.
And then it'll be moving toward the Earth. We're moving toward it. It will cross our bow 22 million miles away on the afternoon, evening of October 16th at 19 hours 50.
Oh, come on.
No, serious, right in the ephemeris. You start looking at this, okay, let me give you what the odds are now that we're up to. The odds of all these coincidences being just coincidence.
I hate that word.
I know. We have now exceeded, where's my view graph go here? Darn. Hold on one.
All right.
Okay.
We're talking about Comet Elenin with Richard C Hoagland. There is a method to his madness.
All right. The odds now are up to 230 million to 1 against chance.
With all those 19.5s.
With all those 19.5. But I'm not done. Remember at Ronco, the guy says, but there's more.
Yeah.
Okay? Elenin is listed by JPL as a hyperbolic comet.
What does that mean?
It means it's never been here before and never will be here again.
It's gone.
It's gone. It's a one of. You know, it's a one of a kind. In fact, what's so bizarre, if you start doing some study of astronomy, in the entire history of astronomy, George, there has never been a hyperbolic comet recorded and verified by all of astronomy. Ever.
Now, how do they know it's not going to come around in 200 years?
Well, but remember, they can calculate the orbit based on positional plots using, Kepler's laws, Newton's laws, gravity. We know what's up beyond the inner solar system. We know that it doesn't go anywhere near close to the other stars. So the orbit is pretty well defined, particularly after it comes through. We'll know exactly when, if it ever comes back again, it's going to come back again. And it turns out that that number is around 11,800 years. But coming in, JPL, NASA has been insisting from day one, this is a hyperbolic comet, meaning it's an interstellar visitor. orbit of the Earth of 1.84 degrees. So I look at that and I say, what are the odds that a random interstellar visitor, never seen before in the history of astronomy, which goes back hundreds of years, right?
Right.
Will have that specific inclination. And I do a simple calculation. There are 360 degrees in a circle, right?
Yep.
You simply divide 360 by 1.84. Now, if you could follow along at home, folks, with your calculator, and George, if you had a calculator there in the studio, you'd now be falling on the floor because the number that the calculator will spit out,
It's not big enough.
195. You have one chance in 195 of that coming up by chance. You multiply that by the 200 plus million I just gave you for the previous odds, we're now up to one chance in 45 billion with a B that this thing is accidental. In other words, all of these orbital parameters, the numbers, not me, the numbers say with a statistical, certitude you could take to Vegas and own the world if this was on your side, that 45 billion to 1, this thing has been designed. The orbit is not random. The orbit is as precise as NASA sending the Cassini spacecraft to Saturn.
Are you saying it's a craft of some type?
It is something. This is where I was several weeks ago. It's something which was sent to us with these specific parameters.
Right, so there you have it. Very interesting indeed. I've not really got much to say about it because he explained it very well. So yeah, I've been on a bit of a roller coaster with Comet Elenin. My thoughts towards it has changed as I've been journeying with the comet on its trajectory as it's been doing its thing. I've been on my journey trying to interpret the meaning of Comet Elenin, and it doesn't seem normal. Now, at the very start, I naively believed it was a brown dwarf star. Don't believe that. I don't believe that now, for the simple fact that the consequences of it being a brown dwarf would be catastrophic. I don't believe that Comet Elenin is going to be an extinction level event. If there is any type of extinction level event, it won't be anything to do with Comet Elenin, but it could be that Comet Elenin is some kind of a timeline, some kind of a calendar to trigger events, but I don't know. But very interesting what Richard Hoagland says there. Now, also he talks about a recent event whereby there was pictures of Elenin's nucleus that was very clearly taken with a flare that came off of Jupiter. I think it was. I hope I'm getting this right. But check out Richard Hoagland's stuff. He's the most interesting person to shed some light on Comet Elenin, in my opinion. Now, he found, and check this out yourself and come to your own conclusion, that the nucleus of Elenin seems to be surrounded by what he describes as a force field. Not saying that it is a force field, just describing it as something that looks that way, that is in the shape of a tetrahedron. Interesting. So, there's some food for thought for you. I'm going to listen to the next part of his interview on Coast to Coast, and I'll update you if there's anything else, but I'll try and link you to the entire interview, because I highly recommend that you listen to the whole thing.